So I'm going to talk about the very simple concept that is clustering, then hidden Markov model and neural network today. So let me start this thing by asking a question that what is clustering? Can anybody tell to me that what is clustering?
Is it grouping of the tasks, sir? So we have multiple tasks, and we can divide this task in group, and then we can perform the required
Correct.
result.
How do we group?
So
Group
based on, yeah,
similarity.
right, sir.
How similar they are. So we want to, and we can also call it homogeneity. So we want to find out that what is how similar they are. So if this few items are similar, we want to tell that they looks like close. So for example, if let's assume that it's a two-dimensional space, x, y, x and y. So there are few here are few points, and if I ask you that, let's assume that these are data points. So if I ask you that how many clusters are there, so can you tell me that how many clusters are there? So initially you don't know that what is the clustering, but looks like that these items are at one place, looks like that they are localized, they are close, they are similar. So you can say that how many clusters are there?
Two.
Two
Two.
clusters are there. So please, I'm sorry that you are actually seeing the screen that I am seeing. So I'm sorry that I cannot see your chats if you are writing anything. So so there are two clusters, but if required that if I say that, so if you put the clustering in this way, so you can say that this is the rectangle class, this is the triangle class. So by this you can say that the two classes we have. Other, if I ask you that no, I want more classes, can you give me four classes? What would you do? So in this portion, then you would look around in this particular portion and try to give two things to me. So looks like that these items are more similar. So you say that they are into one cluster, and these items are into another cluster. By this I get two clusters. Here also I can get, looks like that these are the similar, and this particular thing is away. So I can give four clusters. So cluster may be somebody else from outside may dictate us that how many clusters, how many things we want to disclose, because it's a here we don't know anything about the data, but here somebody can dictate us to take ourselves forward in a particular way. So here you can say that how many clusters are there? Six clusters have been created. So however, we want that when we are going to create the cluster, so we want they should be similar. And here the another idea is also there that they should be different from the other people's. However, it is not that much required. Many other time it is not like that. But we think that if something is into one group, then this is one kind, another kind, and there is a difference between these two things. Okay. So it is unsupervised in nature because we don't provide any information, and unsupervised learning we have to do. And it is useful in summarization because what happens now, if this is a complete data, so how many data points are there? There are 1 2 3 4 5 6 18 data points. So if you want to describe this particular data completely, you have to describe the property of 18 things. But if I do a clustering, so I find out that there are only two groups. So then I can find out some common properties of this group, common properties of this group, and then by representing that information, I can represent all of them. So instead of 18 descriptions, I am going to have only two descriptions. So it is a kind of summarization. I'm going to give the summarization also. Compression, because now the data was more. If you want to compress this data, you can say that only 2 points I have. You can find out their representatives, and you can say that something like that. So they can also help you to efficiently find out the nearest neighbor, that who is neighbor to me, because in most of the cases what happens, if you want to find out that in the database, let's assume that you have a database, you find out that you have a new data point and you want to find out that who is the closest data point to this particular item. So only way to do it is this, that you compare with all the items which are over here. So if you are comparing with all the items, so number of comparison is equal to the size of this particular database. If the database size is very large, it is very difficult to do. Another way could be that if you do a clustering on this and you find out that looks like there are three clusters are there, then by this you find out three cluster centers, and when the item is coming, you just compare with these three item cluster centers, and By this, if you think that this cluster center is near, so you forget about other points matching with other points and you just go ahead with this particular point. So by this, you would be able to do the comparison into lesser number of time. Am I able to see this? Convey this? So what I was telling this point. You are with me? So I was telling that let's assume a database is there and later let's assume that how many items are n items are there. New item is coming and you want to find out that which particular item is nearest to me. So you are going to make match with this, all the items and you get n number of values. You sort them and then find out the minimum out of that. So this and the item corresponding to that particular thing is going to be near to you. I told you another way, and this way says that you find out that looks like that. There are three different clusters over here. So you say that you find out the cluster centers out of them, and then this new item you are going to compare with these three items. So how many comparison you have done? Three. After that looks like that this item is very near to me, then you go into this particular direction, this particular set only, and you find out that which is the nearest item. So how many comparison is needed? So let's assume that for the uniform distribution you can say that n by 3 items are there. So 3 plus n by 3, it is very less as compared to the n. Okay, it is very small as compared to the n. Okay, so it, because here you can say that if I have k clusters, so this becomes this particular value, this is going to be very less. So by this you can fasten the search, and also who is stopping you to make only one layer of this tree. This tree can be multiple layers also, because here inside also you can divide something like that. So then you can see that it is going to be something a binomial distribution set k plus n by k plus n by k square plus something, it becomes something like that. And then this number is actually going to be very less number. So this is what it is. So you can use it efficiently finding out the nearest neighbor. What I mean by that, if you want to do the clustering, that is we can do in multiple way. One method just we have saw that hierarchical way. So initially you say that there are three items, for inside these three items there are five ways, something like that. It is hierarchical. And then you can talk about another way, that is a partitional. And difference between hierarchical and partitional is this, that you actually in the partitional you partition the area. Okay, in the hierarchical you can say that this item, then in the hierarchical we say that this item, then this item, something, you create the hierarchy kind of thing. In the partitional you divide the space into parts and then try to find out that whether the things are in which particular region. uh, there are this particular kind of activity, this particular kind of thing is useful when this particular kind of thing is useful when the data is actually everywhere distributed, but generally it is not the case. What happens now, the data is mostly data is here and here and here. So if you divide into this particular way, it would not be a good idea. So then in most of the cases you go for the tree based hierarchical clustering, that is more suitable for you. So another way could be exclusive over overlapping versus fuzzy. So exclusive matlab every item is going to be given one cluster membership. Overlapping, so we would see very soon that more than one membership can be given. Fuzzy, so when more than one membership is given, then we can tell that what is the probability that it is into this particular class. So this by this we can say there's something fuzzy. Complete versus partial. So this is also very interesting idea. So what happens now? Let's assume that we want to do the clustering, and our data looks like this. That let's assume that our data looks like this. Okay, and we want to do the clustering. So it would be nice that if you only say that looks like that there is one cluster, these items need not to be clustered because they are very away, their density is very less. So this is another way where I'm telling that I'm going to do the partial clustering. Not all the items are actually liable to be put into a cluster, and the another approach is complete. For all the items I'm going to find out that what they are. So today we are going to see in this particular session a particular method of clustering that is called the k-means. And in this method, what happens that I'm going to specify that I want k different kind of cluster centers. So So we are going to see this into much details. So before that, let us see this particular thing, that there could be clustering approaches, such as here we can see that well separated clusters we have here, center based clustering. So there are two centers. So you can see that here is one center. So this particular item here, you can see that they are by this you can only say that this item is here and this item is here. Otherwise what happens that they becomes very fuzzy, because a small change in can change them into anywhere, or since they are connected you can also say that they are into the same group. But because of the center based clustering, you can say that looks like that one center is here and the center is here. So then based on that you divide the thing, you can tell that two clusters are there. Another way could be you say that continuity based clusters, where you say that if the things are connected, they are into the same cluster. So this is one cluster, then let's like that these items are connected, then there is one thing. So these things are into one cluster, and here is a continuity. So these is a second cluster, and here is a continuity. So here is a third cluster. Another method could be density based clustering, where you see that here is a huge density. So this is one cluster. Here is a lesser density. You say that second cluster, and here is a very less density, so you can say the third cluster, or let's say that there is no item. The very interesting idea is the conceptual clustering, which actually says that let's assume that this is the data I have and I have some concept. For example, the concept is triangle, a concept is rectangle. So you actually fit this particular rectangle over here. You say that looks like that these items are actually into one cluster and these are the triangle kind of items. So this is the another cluster. So however there everything is connected, but conceptual clustering can divide these things into this particular way. Here is a also a very interesting idea that I wanted to discuss earlier also, that there are two rings, you can see that. So the item into one ring can be said that they are after type 1, item into second ring can be said as of the type 2, but you can see that there are few overlap also. So here the items, whatever items are there, they have both the membership of the both the rings. So let us go and understand the k-means algorithm. So can anybody wanted to tell me something about the k-means if you have any knowledge? Do you want to tell something to me? Yes. Okay. So let me tell you. Okay. So if you don't have anything to say, let me tell you. So the k-means is a clustering algorithm. K-means is a clustering algorithm. Means we want to find out number of similar set of items. So here k is provided by the user. User provide that how many things actually I am looking for. So how it happens? So let's assume that for the just the sake for the um visualization, let me take that the data is a two-dimensional data. Let's assume that here are few items. Okay, here are few items. Here are four items. Okay, and the idea is this. Please concentrate on this. Idea is this, that user is going to provide the value of k. So can you tell me that what value of k I should take? Can you tell what value of k I should take? Hmm? What
One
value I should? One.
should be
So
three or
if I take one, everything would be one. So the better is a three. So let's assume I don't know, because I would also you can visualize that why you are telling. So let's assume I don't know. I take two only. So algorithm says that randomly select k points at centroid. K points, not the data points. Okay. So randomly select k points. So I don't know. So at the random location, I say that this is one location and this is one location. Let me say like that. That these are the k locations. This is the first step. Everybody clear about this? Next step is that we have to repeat this. What this we have to repeat, and what is there for each datum points, assign it to the closest centroid. So every data item, for every data item, because you know that here if they are like that, so if I draw a line something like that, So all these points would be all the points which are actually here, all the points which are actually into this particular side, they would be near to this point, and all the points which are after this particular line, they would be near to here. So what would happen? I would assign every data point to one of the clusters. So these points are actually assigned to here. They are going to be assigned here. They are going to be assigned here. Okay. They are going to be assigned here. Yes or no? This part is clear.
So one question here.
Mhm.
So the point that we are deciding, they are I mean new points, or can we have the existing points any of them also?
So they are new point. Na? Randomly select k point as a centroid. So centroid is a new point. Centroid was not there. So I am going to give new thing. I told you that they are not data point.
Okay.
So I selected k number of centroids. So k is right now k was 3. So 2. So I have selected 2 points randomly. Let's assume that anywhere I have put the 2 points. Okay.
Okay.
And
Thank you, sir.
algorithm says that you assign every point to them. So this was the point assignment. Have you understood this part?
Yes, sir.
Okay. Now in our case the point has a x and y value. Let's assume that this is x, this is y. Okay. So the second step is recompute the centroid mean of each cluster. What does it mean? That since these points are into one cluster, so for all the data points, forget about this. Now forget about this. For all the data points, find out what is the summation of x and number of points. So let's assume here how many data points? 1, 2, 3, 4, 5, 6, 7. 7 data points are there. So summation of x divided by 7. And similarly summation of y divided by 7. I would do that. So if you take the summation of x of these points and divide, so the point would come somewhere here. Am I right or not? So it would come somewhere here. Yes or no?
Yes, sir.
Okay, because these are the points. Is the summation of x and divided by number 7, summation of y divided by 7 somewhere here. So by this, what I achieved that this point moved from here to here. Yes or no?
Yes, sir.
If you do the similar thing here, what would happen? Because here the more data points are there, here less data points are there. It would be shifting something here.
Mm.
Yes or no? Same thing something here. Then
Yes, sir.
again, this algorithm says that until the centroid converges. So has it converged? No, because converge no, because it has moved. So I say that I would do the same thing once again. So what does it mean? That forget about the thing. And now I have the new centroid. So with the centroid, what to do? You know that what to do. So it is very difficult to actually remove. I would not going to do that. So again the same process. So again the same process means you draw a line between these two things. So it looks like that the line would come something here. Yes or no? If you
Mm.
reassign the thing, these items would be assigned here. They would be assigned to this. If you recompute the centroid, looks like that it would come here. This time the centroid would come here because now earlier even less points are there. This would shift something here to cater the need of these points. So again, if you divide the things, so it would become like this. So it would become now this would be the thing and it would come in between center of here. After that things would not change and it would get converged. Are you able to see this?
So basically, sir, initially we need to consider the cluster, and
Mhm.
then uh, after deciding the new point, we can consider the data point. So this we need to continue until we complete the finish the process.
Okay, you understood this point. Okay. So essentially what we have did, we started with the random centroids and then we have did the assignment and after every assignment I am going to recompute the centroid and I keep doing this until there is no movement into the centroid. When there will be no movement into the centroid, when all the points are there, if there is no cluster assignment change, there is no change into the cluster assignment, then things would stabilize. I would say that these are the clusters. So very important and very basic algorithm. And this here how we decide that which items are closer. We have utilized the Euclidean distance. Again, this is the second example. So where
Sir, what is meant by until the centroid converge?
okay. So I was telling na. So when you change this, I mentioned this. Let me tell you once again. So every time I was telling that when he initially centroid was here, It has moved to this place, yes or no?
Yeah.
After that, it has moved to this place.
Yes.
But when it moves to this place, then the line becomes this. Then the assignment was this. If I again do the assignment, it may move here.
Yeah.
Okay, and this would move here. After that, if I do the assignment, whether the assignment would change?
Yeah.
No. It is very less moving, na. After that, these earlier also these were assigned. Now, if I do the assignment between them, this is a
Okay.
different line, but the assignment is same. So whether it is moving,
Okay. When centroid stops moving, it
yeah,
ends. Okay.
it has converged. Yeah. Another example, and where let's assume that these are the data points. 1, 2, 3. These are data points. So forget about the colors. Colors actually says that if I randomly pick 1, 2, and 3, these are as a location. So I would assign these point to here, these point to here, these point to here. Make sense? So when I compute in the next step, I have to compute the centroid of these points. Centroid of these points would be something here. So it moves here. Centroid of these points is somewhere here. So it moves here. Similarly, you can see that. Yes or no?
One question. In this case, what was the K value? Is
K
2
is
or
3,
3?
na? K is 3.
3.
K
Okay,
means,
thanks.
yeah, K is 3 because three things are there. So 3.
Yes.
So let me make it big. Yeah. So here in my case, for how the things are happening, I was telling that since the centroids are shown, okay, how many centroids are shown? 3 centroid in here, 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 and here. So 3 centroids are there. So for these points, center, if I recompute, the things would be here. For his, it remains the same. But when this changes, so the place changes like something like this. So assignment changes. Then again I compute, so it may move here. So I find out this thing, this assignment. Then again it moves. So you see this assignment, after that this assignment, after that this assignment, nothing is changing. After 6 iteration, I can find out this is one item, this is second item, this is third item. So again the same kind of visual interpretation that you can understand. So if a key means algorithm has been given to you, how can you tell that how good this algorithm is? How can you tell how good this particular algorithm is? Okay, sorry, how good this clustering is. So actually, what happens that because it's a random thing, na. When I started by random positions. So this by this what happens that if I pick the centroid here and here, it may be possible I can select here and here also. I can select here and here also. Anywhere I can set. So it may be possible that in some corner cases I select in such a way so that the value is not good, means the clustering is not good. So I can get the different kind of clustering also. That I wanted to make the point. It may be possible. Do you agree on me? It may be possible because I started from the random place. It may be possible that I could not get the good cluster. So the idea is this, that let's assume that that few points are there. Okay, few points are there, and you are telling that these points are into some clusters. So I would find out that what is the cluster center. I say that mu1. What is the cluster center for 2? Cluster mu2. What is the cluster center for this? Mu3. So with this particular item, I would see that what is the distance of all the items which are actually into this particular center. Okay, with this point, what are the distance of these particular points? So if I find out that what is the distance of the items with respect to their centers, and the square is just nothing more than this, that I want to focus the highest value. So for all the centers, for I is equal to 1 to k, for all the clusters, one cluster, second cluster, third cluster, k is equal to 3. For all the items which are in that particular clusters, I am going to find out the items which are actually here. Okay, uh, I'm going to find out this particular value. So this particular formula was clear to everybody. This formula is clear to everybody. Yes or no? So what I'm telling once again that for all the clusters, so 1, 2, 3, k is equal to 3. So 3 time I'm going to find out. For one I would be here. then what I would do, I would see the distance of this particular mu. Mu is the actually center, and for all the data points. So for all the data point, I find out this particular distance and summation of all these things. So if somebody gives me another cluster, for example, he gives me this cluster, this and this, only two clusters, or somebody gives me this cluster. So for all the clusters, all the possible kind of cluster, I am going to find out this particular quantity. So that particular division which gives me this value as a smallest value is actually the good one, because I want to minimize this particular quantity. Why? So that the better cluster would be actually minimizing this particular quantity. Yes or no?
Yes, sir.
Yes, no? So this is a very interesting idea. So this is how we evaluate. If the multiple kind of things are given to me, multiple kind of clustering is given to me, I can tell that which clustering is better. How to choose k? Then the remaining question, the question remains that how to find out appropriate value of k, because we don't know about the data. So the idea could be that one idea could be that run the k means multiple number of times, and every time you evaluate this particular thing and tell that which is best. Okay. So with a different value of k, this particular quantity is the sum of square errors. So you see that what is the sum of square errors. So if you increase the value of k, definitely this value is going to be going to reduce. But you can see that it is going to reduce in this particular way. Okay, if you change the value of, because if the k is equal to number of items, so for every item you can find out the representative. The item is itself representative of itself. Then what happens? Here it would be 0, because every item has the uh, his representative. So distance would be 0, but this we do not want. We want the value of k should be lesser, very much less as compared to the number of items that we have. So somewhere here we want to stop. So how can you measure that particular point? One method is elbow method, that tells that you plot this particular curve and with respect to k. So at the place where you see this thing, so this kind of behavior, so this is called the elbow behavior. Elbow, na? Do you understand this elbow? So what happens now? So you can see, let me just draw this, would be clear too. So you can see that initially what happens, that when you increase the value of k, it is reducing with this speed. Okay, but after that it is reducing with this is speed. So you see that this is speed and this is speed. So it looks like that here is an elbow. Okay, if something is like this, you see that here the speed is this, here the speed is this, looks like that this is the elbow point. So here you can say that I would stop and take this value of k as a value of right value of k for me. Okay. So one way we have just talked about, that iteration of k can give me the choosing the value of k. Another way could be if you by yourself know that looks like my data, something like that, you have domain knowledge, or you pre-process using another.
So what is that point, elbow point?
Say again.
What is that point, best point for K? L in the graph.
Yeah.
What's the name of
So
that?
this is the elbow point, na? So near about
Elbow
any,
point. Okay.
yeah, elbow point, you can just see that somewhere you can just pick that particular point k. That would be a better k.
Okay.
So as I told you that you do multiple iterations and find out the k. This is we are discussing, and another way could be that you from domain knowledge you know that what it is, or you apply some other algorithm to discover the value of k, and then nearby value you can explore. Center initialization, again, we have talked about that you can do it randomly, or another way could be that random points of data you pick, or look for the dense region, the places where there are more data items. You pick more number of representative there, or you space these points uniformly into the feature space, and then you find out that you start doing this k means. Cluster quality, we have just discussed that one method, that how to do that. However, there could be some limitation of the k-means. So I am going to show you a carefully selected example where let's assume that these are the data points. Okay, let's assume these are the data points on, and I have also shown them that these are the one class, another class, three classes. But if I carefully select, initialize the item cluster centers in such a way so that the first I'm going to put here, and second and third I'm going to put here. So it may be possible because these items are assigned over here, and I put two cluster centers over here, so half and half they are going to divide. So the clusters are going to come into this particular way. Can you see this? Is it a right way? Answer is no. So carefully selected the way it may be possible, or I can say that accidentally it may happen that you choose the initial points in such a way so that right kind of clustering is not able to be achieved. Okay. So K means some has some of the limitations, such as different size of clusters when there are different densities when there are non-globular shape there are. It assumes that the things are going to be circular only because of the distance. So then it becomes not a good choice. Handling empty classes is not possible because it may be possible that let's assume that you decided that there are three classes, and after some time what may happen that few items are getting deleted. So if every item is deleted, then the concept actually loses for that particular cluster. When there are outliers, for example, when a lot of outliers are there, it seriously affect this particular algorithm, and it is very difficult to update the centroid incrementally. Just a caution, point of caution, that there is very important two important name. One is k means and another is knn. Knn we have seen in the last class. That is a different algorithm. K means algorithm we are seeing here, that is for the class, that is for the what that is called the clustering. Knn is for classification. Kn is a supervised approach for the classification, and K means that we are seeing it is clustering approach, that is unsupervised. Because of this K appearing in both the places, we do this kind of sometimes we get confused and we get wrong answer. It is a very frequent question into the interviews, and if you answer it wrongly, then they think that you don't know anything. Okay, so there are a few more approaches such as K-mediated, agglomerative hierarchical clustering. DB scan is another very interesting approach that actually try to apply the things in such a way so that when there is a huge density, larger density, then for those items it is going to do the classification clustering. But for the items where there is a sparsity, it actually says that I'm not going to give any kind of label to them. So these are some of the methods. Next thing that I wanted to talk to you about the Markov model. Okay, hidden Markov model. So to understand the hidden Markov model, first let us understand that what is a Markov model. So does anybody have any idea about the Markov model? Hmm? Tell me.
No, sir, no idea.
No, sir, no idea.
All of you know this. Let me tell you, because I'm telling Markov model, you are thinking that you don't know. So the idea is this, that some phenomena happens. Let's assume that A is some phenomena that happens. What is that phenomena? Let's assume, I'm going to give you out of context example. Let's assume that there is winters, then there is summers, then there is rain, and after that again the same cycle repeats. These three things are what? I say that there is some phenomena. Understand? This is applied on our Earth. In which year? 2001. Let's assume that in 2000 it has been applied. Then this is what the Earth position into 2001. Yes or no? So there are three seasons, na? Winters, then am I right or wrong? Then there is summer. Then after that there is a rain. After these, 1 year completes, and then we go to the next year. So if this is the x, let's assume that x0 represent that what is the Earth position into the year 2000. Then x1 represent what? What is the Earth situation in 2001? Am I able to tell you?
Sir, but Earth location next year. So we are not talking about the time. So basically, Earth location will be same.
Hmm.
But if we compare the season wise, like in summer the Earth position is different, and in the autumn or in winter the Earth position is different, then we should be able to differentiate it.
No, no, I'm not telling you any differentiation. I'm telling that what is A? A is,
Eh,
let me
let's
define.
say here summer,
Let me define. A is three seasons,
right?
1 year. A is 1 year.
Okay, got it, sir,
So I
got it.
applied this thing on the Earth. So what is X1? 2001.
2001, yeah,
I
got it.
again applied A. It becomes A2, A3, A4, A5,
Yes,
A22.
yes, yes,
So there is
got it.
some. So what is Markov model? That there is some processing that is A. I am going to apply some data. Same processing is again applied. Same processing is applied. A multiple number of time I am going to apply the same thing.
Right.
This is called the Markov chain. Okay. In the Markov chain, there is something that I am going to apply on the data, and by this the things are going to change. Very simple. So you by yourself understand that whether the Earth would be changing, maybe different. There would be some change. Okay. So point is this, that if uh, I don't know that from where it is started. So the point is this. Let's assume that I say this. So point is this, that Earth is for very long. Na? I know that what was Earth in 2000. After that I applied the same thing. I get what is 2001. After that I applied what is Earth in 2002. Something like that. I'm going to do that. So point is this, that if I just concentrate on this particular year, okay, so I can say that everything that has been happened to the Earth is been encoded over here, and I need not to define anything. I need to define this particular thing. I need not to use the previous what has been happened earlier. Or for example, if I wanted to find out what would happen in A 2003, I just consider this particular part and apply the A on this and to get this particular thing. Need not to consider everything that has been done earlier. Make sense? Make sense?
Yes, sir.
So in the Markov model says that future is independent of the past given the present. So if the present is given to me, what is right now I have, and I have an operation, I can apply this operation to get that what is going to happen next. I need not to see that what has been happened long past. I need not to have that. If this is my model, so if this is my model, what is my model? That if you want to find out what is going to happen next, just see that what is there, you apply the operation here, you will be getting what is the next over there. So all the previous thing, I assume that all the previous thing are actually encoded over here. I need not to go beyond that. Okay, if this is my model, this model is called what? Nobody is telling. What is this model?
Markov model, sir.
Markov model. So is there anyone who was not knowing this earlier?
I was not knowing.
Are bhai. You are not knowing the name. Everybody thinks the thing into this way only.
Right, sir.
कल क्या होगा? That you want to find out. तो आज whatever the situation is, you apply the something on that. You don't think that.
Prediction, sir.
Next thing, if you, this is the, no.
Past.
You need not to consider all the history. So you see what is today. On the today you apply something, you would be getting something tomorrow. Okay. If this is the model, that if you want to see that what is going to be next, you only consider the current scenario. This is called the Markov model. Okay. So here IID means it does not work. IID independently identity distributed. Something is not knowing to be known. So what does it mean by this? That things are actually changing. So they everything things are not random, because I'm going to apply a kind of thing now. So things are actually moving into particular direction. I have an example, a very simple example. Suppose a company is selling a product. There is a company who is selling a product A. There is a product A, and it has a market share of 20%. What does it mean? So let's assume that there is a shampoo. Um, um, Shampoo name, there is a shampoo name Bisleri. Okay, Bisleri has how much market? 20%. Means out of 100 people buying what?
20%
Shampoo,
people buying Bisleri shampoo.
Bisleri sample, yes. And he is going to launch an advertisement campaign that is expected to retain 90% of the old customer and attract 70% new customers. Okay. So what would be the maximum market share of the product I can get? You understand? So I can represent it this in this way, that A is a product and A dash is a product, means all other people's, all other product, all other shampoo are here. Okay. These 80% people are purchasing these things. Okay. 20% people are here. So if he launches that particular advertisement campaign, then 90% people are going to remain here. Yes, this line is clear.
Yes.
And other people who are purchasing the other product, they are 70% of the people, or 0.7% of people are going to purchase this particular item. 10%, because you are able to only attract 90% people, it means that 10% people even after the advertisement are going to leave him and going to purchase other items. In the same
Right.
case with the A, 30% people are going to be something like this. So initial state is that A is 0.2, others are 0.8, and this is what the transition matrix I have. This is scenario I have. A, let's assume that A is 0.9, A B is A dash is equal to 0.1, 0.7, 0.3. Are you able to understand this matrix?
Yes, sir.
Okay,
Yes, sir.
great. So if this was the initial condition and this was the transition matrix I have, I can multiply this. So initial state was this. When I multiply this, I said I get one iteration after one advertisement campaign. This is the scenario. So 74% market share would be for the Bisleri and 26% for others. Fine. Fine. You see that 0.2 multiplied by 0.9, 0.8 is multiplied by 0.7, the summation becomes 0.74. How many people are leaving? You just see this multiplied by 0.1, 0.8 multiplied by 0.3, this is 0.26,
Understood, sir. Understood, sir.
correct? So,
Yeah.
so if this is after 1 year, after one iteration, after 1 month, so next month what would happen? You put this value over here and multiply with the A. Because now this is the scenario, na? On this, if you apply again A, this is going to scenario.
Right, sir.
Next year you apply this and you keep doing this. So you can
Until
see that
until
initially
second
for,
and until this is zero.
so initially it was 2%, 0.2, then 0.78, then 0.74. So you can see that initially the profit was more than 0.5. After that profit was 0.1 only. Then it is even less than 0.1. So if you keep doing, what would happen here? It would become 0.
Zero. Yes, sir.
So this is what the question is, whether it would become 0 or not. My point is that it would never become 0. Okay. So I want to find out how. So there is something a very interesting concept that is called a stationary matrix. Let's assume after some time AB, if when you multiply with A, it is not going to change something. Again remains AB. Sorry. So if A is a stationary matrix, if AB is multiplied by A and then it becomes AB only. So here in our case 0.9, 0.1, 0.73 is equal to AB. I am not going to the detail. You try to solve this by yourself. You would be able to find out the value is 0.875 and 0.125. So what means that if this value becomes 0.875, 0.125, after that you keep multiplying, it is not going to change. This is the maximum that you can get. There will be a stability. Okay. Question is, does it always happen? So answer is no. If the matrix is regular, then only. Regular matrix means what? If you multiply a to the power a, you find out a some power of the a, such that all the values are actually positive. Okay, all the values are positive, then it is a kind of regular matrix. And if this is a regular matrix, then definitely this kind of scenario is going to achieve. For example, I give an example that whether this matrix is regular or not. Yes, it is regular because all the values are initially positive. This is another matrix. Is it a regular matrix? No, because if you multiply this matrix with itself in how many times, whatever number of time, it is going to be at least there will be at least 1 0. So it is not regular. So if this is kind of scenario, it is. So it is not going to be stationary, and this scenario would not arrive. Again, this is another example where at some power you would be able to find out that all the values are non-zero. Everybody understood that what is Markov model? Markov model, you are going to apply something, you are going to get something. Okay. Now what is hidden? And let me talk about our topic, today's topic. Today's topic is hidden Markov model. What is hidden Markov model? So hidden Markov model says the same thing, that there is some state. I need your participation. There is some state, you apply something, you get something. You again apply something, you get something. You again apply the same thing, you are getting something in this particular way. This is clear to everybody, Markov process?
Yes, sir.
Yes.
Okay. But actually what happens, sometimes this X is not accessible to you. This state is not accessible to you. You don't know that what is the value of x1, x2, x3. Sometimes you don't know that what is the value of x1, x2, x3. But you have some way to access some other thing, that is an observation on x1. Observation you can have. So yeah, that I think this part I have to tell to you that what do I mean by this. So I want to take you to the history. शिमला समझौता किसी को पता है? Anybody knows? I also don't know. Okay, if there is any
agreement that happened.
Tell me.
The agreement that happened between India and I guess Russia. Simla agreement. No, that was Tashkent. Like something like that I've heard.
So I have not also heard. If there is any historian, please pardon me. Okay. So let's assume later also if somebody is listening and I am doing wrong, please pardon me. Let's assume in 1931 there was some similar samjhota. Okay. And next year next day 1931 for example January 5 it was happened like that. Then what, there was January 6, then there was January 7. These are the dates. Let's assume that these are the dates. Okay, January 8, January 9, these are the dates. I wanted to find out that what was the temperature on that day. What was the temperature on that particular day? What is the, because it was happening over there, I wanted to do something, and also I want to find out that what was the temperature on that particular day. So my question is, can I know this particular temperature? It is going to be very difficult to know. Okay, what is the temperature over here? It's very difficult to know what is the temperature, because on that day, if I don't have anywhere written that what is the temperature over there, can I get this information? Can you tell me? Can I get that what is the temperature on that particular day?
If you don't have record, we cannot.
You cannot do. But you know that there was a newspaper, the Times of India was actually publishing. Times of India was publishing newspapers on that day. So let's assume that Times of India is publishing the news on all of these days. But he was also not reporting the temperature. But he was actually at that particular time. It was something like that. That let's assume that instead of temperature, I wanted to find out if what is a hot day, what is a warm day or cold day, something. Okay, I wanted to find out these three classification. What is cold or hot or what, some kind of day. Let me also assume that let us say that I know this particular thing, that if it is a cold day, then this Times of India is going to print something about coffee. A large coverage it is going to have of the coffee. It can also be medium coverage or no coverage on this, but the probability that large coverage is there is 0.7. Medium is 0.2, no coverage is 0.1. Let's assume something like that. Let's assume that I have this information on the cold day. On the hot day, the same thing, coverage of the coffee is 0.1. Coverage of something, I know this particular thing. Okay, so I don't know that what was the actual temperature on that particular day, but if I pick that newspaper on that particular day, by seeing this by applying this some kind of understanding of this kind of thing, I can guess that looks like that because a lot of people are talking about the coffee on this particular thing, lot of people are talking about ice cream on this particular day. It looks like that this is a hot day. Lot of people are talking about coffee on this particular day. Looks like that it is cold day. Can I do something like that or not? Does it make sense?
Yeah, we can make some assumptions, sir.
We can make some assumption. It may not be correct, but we can find out that what is the probability of this thing. So here, what I wanted to tell you, I wanted to tell you this thing that I did not know that what was the actual value of this thing. Yes or no? But I know something, some other thing about this, and using this thing, I can guess something about this particular quantity. And it here what I wanted to tell that actual state is hidden to me. Actual state is hidden to me. What is accessible to me? That this newspaper, and by this newspaper I have some observations. I have some observation that what are the coverage of the coffee, what are the coverage of something. I have these observation. Using this observation, I wanted to guess that what is the state of that particular thing. And this is a very general kind of setting. Let me tell you that it's a very general kind of setting. We don't know anything. For example, what is happening in my mind, you don't know. Whatever I'm telling, based on this, you may be thinking that my professor is excited or he's not, he's dull or whatever. You can think about that. But what is happening inside me? Why I'm dull? Why I'm excited? Why I'm saying you don't know. Okay, so what is generally it is happening, you don't know all the concepts over the word, but you have some other things to see that how he is behaving. For example, how your friend is behaving. Based on this, you know that looks like that there is some bad with him or good with him. You know about that. You don't know that what actually had happened. Am I right or not?
Yes,
This
sir.
is this
And
is the
maybe
general.
dressing system can also, sir. Maybe this dressing system, we can have a look at the newspaper. If newspaper has published some kind of photograph, so by looking at the photograph, we can see the dressing
Dressing.
system, and then we can also assume.
Correct. You see that what kind of photographs are there, what they are wearing, and based on this, you can have the assumption. So I say that there are some kind of, there is another matrix B that if you multiply on this, you'd get, because they have actually applied this matrix and find out, and that's why they have actually published in the paper. And I'm just telling this vague idea, but some kind of observation you have. So actually, this is what happens, that you are on this particular, there is a state, but you are actually having some observation. You are applying A, you are going to change to another observation. You are again applying to A, then another observation, another observation. By this, your observation is actually changing. You actually don't know that what was the state. Am I right or not? You
Yes,
actually
sir.
don't know the state, but you know only the observation based on that. Now, so let us come back to our problem. Assume that we observe that the news coverage is small, medium, large of some article to know whether a day was hot or cold. And let's assume that this is what the matrix I have. On the hot day, the probability that the small coverage would be there 0.1, medium coverage is 0.14, large coverage is 0.4. On the cold day, small coverage is 0.7, medium 0.2, large is something like this. And this is another matrix that there is one hot day, next day is going to be hot, the probability is 0.7. It is a hot day, next day is cold, its probability is 0.3, because you know that hot day next day is also going to be hot only, difficult to get cold. Cold day next day is going to be hot, probability is 0.4. Next cold day next day is cold, probability is 0.6. So this is what I have. Okay, if this is the setting I have, everybody understand this? Because this is how the day changes. The hot day becomes hot or cold, something is going to happen with this probability, and by this matrix we want to understand that what is happening into the system. Now now my question arises. Okay, now my question arises. I'm going to solve a particular problem. Okay, and the problem is this: delete control V. I'm going to say this, that here let me say this. Okay, so this is what the setting is. Let's assume, please focus. Okay, that on, let's assume that initially I know that this is the first day what there was a probability that it was a 0.6 probability, 0.6 probability it was a hot day. Let's assume that it was a hot day, the probability was 0.6. And on the paper I see that it was a small coverage, medium coverage, small coverage, and large coverage. On the paper I see that first day was hot, it was However, I'm not sure about this. The probability that somehow I figure out that the probability that first day was hot was 0.6. And then I have opened the newspaper for the 4 days. I saw the coverage was small, coverage was medium, coverage was small, and coverage was large. So I can guess that what is the configuration. I can say that it could be hot day first because high probability. Then I can say it maybe next day could also be hot. Next day would also be next day. Let's assume the cold and next day is cold. It is possible. It is also possible hot, hot, cold, cold, hot, hot, cold, hot, hot, cold, 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 hot, 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 cold. So different kind of configurations are possible. Okay. So which is the most probable configuration? Which is the most probable configuration? Which looks like that the best configuration? So looks like that most probably this is going to be happen. So if I want to find out that what is the probability that today is hot, next day is hot, next day is cold, next day is cold. What is the probability of this? So you can find out the probability in this way that what the probability of hot is 0.6 today. You know that it has been provided to me. Next, this 0.6. What is the probability that if it is a hot day, and a small coverage, hot day small coverage is 0.1 multiplied by 0.1. Okay. And then from hot day, next day is going to be again hot. Hot to hot day, the probability is 0.7. 0.7. And on that day, the coverage is going to be medium. Hot day, medium coverage, hot day, medium coverage is 0.4. 0.4. From hot day, next day is going to be cold. Hot day to cold day, the probability is 0.3. On that day, the coverage is small. Okay, cold day, small coverage. Cold day, small coverage, 0.7. 0.7 coverage, 0.7. Cold day, next day is cold. Cold to cold. Cold to cold is 0.6. On that day, the coverage is large. Cold day, large coverage, probability is 0.1. So this is what, if you find out this particular quantity, it is going to give you that what is the how good this particular thing is. So you can find out this particular value. Similarly, as I mentioned, that different kind of states are possible. For everything, you find out that what is this particular value. So these are all the things which are possible. If you find out these value in this particular way, their summation should be 1, but actually because of the different kind of multiplication, this value is not going to be 1. So you find out the summation and then divide by all the numbers so that the summation becomes 1. So this is called the normalization. After normalization, the probability is actually increases. So this is the highest value, 0.9. Out of all these things, you see that the highest value is this. So most probably it was the cold day, then cold day, then cold day, then hot day. This is what it is. Dynamic programming says that this is cold, 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 hot. However, hidden Markov model says that on every day you find out that what is going to happen. What does it mean? It means that that on every day, day by day, you try to see that what is going to happen. Okay, day by day. Let me see. So on the first day, let's assume that on the first day you see that these are the values. Okay, so here is the hot, here is the cold. So for the hot values, you find out the summation of this quantity. Cold values, you find out the summation of this quantity. This summation comes out to 0.18. This summation comes out 0.81. So on that day, probability of cold is high. So this day is going to be cold. Okay. For the second day, you see that here it is hot. So find out the summation of these things. Again, there is a hot. Find out summation of these quantities. Then sum these quantity. You find out this value. Find out summation of these things, find out summation of these things, you find sum of these quantity and you get this value. So highest is this, so next is hot, next day is hot. On the third day in the same way, you see that these are the two hot, so you find out the summation of this. Again, here is a hot, you find out the summation of this, there is a hot, find out summation of this thing, and you for sum of all these things, the summation comes out to be, I think here I'm going to giving wrong. So summation is going to be 0.22. For remaining values, the summation is going to be 77. So on that day, it is going to be cold. Similarly, for the last one, you see that it is hot. So this is what the most probable configuration. Okay. So this is what the hidden Markov model is, where he says that if you don't know about the thing, it is fine to go ahead in this particular way. Hope it gives the answer of give you something new. Any questions on that? What is the advantage of this thing? Even if you are not knowing these states, using observation only, you are able to tell that what was the possibility on that particular day. This is what the importance of this particular model is. So I'm going to talk about the neural network. So before that, I have a problem. So can you solve my problem? The problem is this, that I want to find out the linear classification. You know, what does it mean? So let's assume that two values you have. Okay, one value is x1 and another value is x2. When the x1 is 1, x2 is 9, then it is green. 10 9 is green, 4 7 is green, 4 5 is red, 5 3 is red, 4 9 is green, 4 5 2 is red. Similar way. So if I have a new point, can you tell me that how I can find out the classification? How can I develop the model? So the first step would be to understand the data. Okay, so let me plot it. One side there is x1 and the side is x2. If I plot, looks like this. If it looks like this, looks like that. Okay, it's very good that if I draw a line like this, I would be able to change the thing. So since the data is linearly separable, so I somehow find out that 2x1 plus 3x2 minus 25, if this value is greater than 0, then it is green, otherwise it is red. Make sense? Yes or no? Otherwise it is red. Make sense? And this equation, if you draw, this line passes from here. Yes or no? Yes. So believe on me that if you draw this line would be passing from here. Any point that is greater that have this value greater than 0, then it is here. Less than 0 is here, because line actually separate the places into two two regions. Okay, so I have developed a model. If a new point is coming over here, I can put it here and find out that what is the classification, yes or no. Yes. Okay, so 2x1 plus 3x2 minus 25. So if new point is coming, I take the x1 value multiplied by 2, take the x2 value multiplied by 3, subtract minus 25, and then find out the summation of these quantities. This summation represents the term by term multiplication. I can say that these are the weights, and then I take something out, that what is the sign, I take it out. Yes. Yes.
Yes, sir.
What is happening here? Are you able to see this, my screen?
Yes, sir.
I have done any wrong? Okay. So this illustration, this kind of illustration that I just showed you is called the perceptron. What is perceptron? Perceptron is a linear decision boundary. Is a linear decision boundary that is represented by in this way, that there is a computational unit that find out the term by term multiplication, and after that tells what is the sign. Here in this perceptron, minus 25, 2 and 3 are what? They are parameter. Question is that how to find out the right parameter given the data. For a given data, I have actually constructed this, but I have not told you that how to find out this equation. So this is the remaining question. If somehow somebody can give me this equation, then I can create the perceptron for that. For the given data, I can create the perceptron. Yes or no? For given data, my task is to create the perceptron, so that if a new value comes, I can put it here and find out that what the classification. Yes or no?
Yes, sir. If we have the equation and
If we have the
data is
equation, how to find out the equation, I have not discussed. I am going to discuss now. I would discuss later. So if equation somehow you can find out, then you can create this perceptron. You know that perceptron is a linear decision boundary. You know this particular part. Okay, how to find out the right value. So this is the important algorithm called perceptron training rule. It says that for the misclassified examples, for the misclassified example, misclassified example, what do I mean by misclassified example? So misclassified example means, so let me give you, let's assume that you have a database. Okay, let's have you have a database. on the database the points are given to you, and after that it is given that it is yes or no or red or green or whatever the classification is given to you. So what I say that this was the equation na? Just for example I say that w0 plus w1 x1 plus w2 x2 greater than 0. Okay, can I write the equation like this? Can I write the equation like this? Here my objective would be to find out what is the value of w's. Once again, what is these w's? Am I making sense? Please tell me. So these are the items. So I say that x1, x2, x3, these are the properties. If these are the properties, so I say that w1 x1, w2 x2, w3 x3. My writing is not that good. w3 x3 plus w0. I say that if this quantity is greater than 0, I say yes. Otherwise, I say no. Red 0, 0, 1, minus 1, plus 1. I can say this. Let's assume that two classes are plus 1 and minus 1. Okay, for the sake of clarity, let me take that two classes are plus 1 and minus 1. So I can write the equation like this. I have to find out the values of w's. This is my problem. My problem is to find out the right value of w's. Yes or no?
Yes.
Yes, everybody?
Yes.
Yes, my problem is to find out the right value of w. I don't know. So let's start. Let's initially take it random values of w's. Take random values of w. And after that what you do if you take the random values, so and you have a now you have an equation, you use this equation to find out the classification over here. So if you apply the classification, somewhere you would be right, by chance you would be somewhere right, somewhere you would be wrong. Yes or no? Somewhere you would be wrong. So for the places where you are wrong, you are going to correct these weights, so that this becomes correct. Okay, how you are going to correct? So the formula is this, that you are going to change the, for the misclassified example, you are change the values in this particular way. How? That weight is equal to weight plus eta time target minus output into xi. This is the formula. What this particular formula is? What is target? Target means what you want. Let's assume that what is target and what is output. Target could be plus 1 and your output could be plus 1 or minus 1. Target could be minus 1 and your output could be plus 1 and minus 1. So if the target is plus 1, output is plus 1, it is correct. Target is minus 1, it is minus 1, it is correct. But in these two cases, I have a problem. So in this case, if I want to find out what is the value of target minus output. So target is what? Plus 1. Target minus output is 2. Am I right? In this particular case, when there was a problem, target was minus 1, output is plus 1, it is again become minus 1. So here the value is target minus 1 is minus 2. Here it is plus 2. Eta is just a number. Let me say that it is half. If I say that half, then it 2 becomes eta multiplied by this particular quantity becomes either 2 or 1 or minus 1. You can say like this, plus 1 or minus 1. You can say that actually this particular quantity is going to tell that whether I am going to increase the weight or decrease the weight. Okay, yes or no? Are you able to understand this particular part? Target minus output is going to tell whether I'm going to increase the weight or decrease the weight. Okay. All right. So if there was let's consider this particular problem. My output was minus 1. It should be plus 1. How can my output be plus 1? If I increase the value of weight, then the summation would be increasing and my output would become positive. Not able to understand. So let's assume that I have a formula and this output is going to give me minus 1. So if I increase the value of w, let's assume that all the x are positive. All the x are positive. If I increase the value of w, then negative is going to reduce, and after that sometime I can be positive also. So I should reduce the weight or I should increase the weight. Tell me. Once again, let me ask the question. Everybody, please focus on this and please answer this question. It's a very important question. I have an equation. That is going to give me a negative value. Okay. And there is a weight. Let's assume that the multiplication of all the x are positive. So if I want the positive output, should I increase the weight or decrease the weight?
Increase the weight.
Increase.
Increase the
Everybody
weights.
clear? Clear about this? So in this particular formula, it says that W is equal to W plus something, target minus output. plus xi. I'm telling that these are the positive. So if this value is positive, for example, into this particular case, this value is 2. What is the case? When my output is negative, this is the case, my output is negative and I want this positive output. And this case, what should be happen? That weight should increase. And you can see that here, because this value is positive, weight plus something positive plus eta means the weight is my weight is increasing, means actually this formula is correct. Let me see the another case of the error. This is the another case where I have a formula that is going to give me what? Negative. It is okay. I think this is not the wrong thing. I'm doing wrong. Here I have wrong. Na? When the my expected output was negative, I'm going to give positive. So in this setting, my thing is going to give me positive. I have a weight. I want what? I want negative. So my weight should increase or decrease?
Decrease.
Decrease. So you can see that this value is target minus output is -2. So if I put target minus output in -2 means what? It is a negative quantity multiplied by x, and then W is going to reduce. So it says that this formula is correct. So after some time, it is going to give me something. By this, my things are going to converge. So this strategy is going to converge. We have just talked about that in what case it increases or decreases. So in this particular case, so I have set a small value of eta in this particular formula. Eta was set to 0.01 and I started with the 0.5, 0.5, 0.5. Then the number of error points were 7. Use the same formula to change. The now error becomes 6, now 5, now 4, 3, 2, 1. You can see that error is keep changing and after many time it becomes 0. So let me give you the visual interpretation. Let's assume that these are the point that I have. So initially when 0.5, 0.5, then the line was this. So all the points are above. So why these red points are above? So there was an error. So the error was on 7 point. When I change it using a formula, line becomes this. So they were positive. You can see that these 1, 2, 3, 4, 5, 6 point there was an error. Similarly, if I keep changing, when I change the parameters, so you can see that the decision boundary was actually changing, and at this point there was no error. If the data is linearly separable, using this particular formula, I would be definitely able to find out the right parameter. Once again, what I told you, that if the data is linearly separable, then you would be able to find the thing. But if the data is not linearly separable, then how come the line can work? So the line would not work. You don't know. But very important thing is this, that in this particular explanation we have seen that the number of error points are actually coming up and down, and after that sometime it becomes 0. When it becomes 0, I would stop at this particular point. I would use the weights associated with this particular position as an output. Error was going up and down. This was the problem. So if the data is not linearly separable, then what we can do? We have a big problem that where to stop we don't know. So the next method comes into the picture, that is called the neural network. So we are going to talk about the neural network very soon. So neural networks are actually different kind of architectures. So this is also a part of neural network. You can see that this architecture, this perceptron is also thought of as a linear decision boundary and starting point of the neural network, but we are going to see this into the more detail. So neural network architecture, you know that it is inspired by human cell, and this has a huge history. You saw that even people have actually trying to understand that how the brain works in 1872, and the first experiment was done by McCulloch and Pitt. They actually given the model of the neuron, that how it works and how the learning happens, and a lot of things actually happened in this particular area. I will not go into that particular detail. If you need, we can talk about this later. So perceptron, by after that they have proposed some model that was actually related to the perceptron. That few minutes back we have seen that what is this, that with the x inputs, with the weights, you are going to find out the summation, and then you apply the threshold to find out that what is the classification on this. So here is an example. Let's assume that here the weights are plus 20, plus 20 and minus 30, and x1, x2, two inputs are there. See, both the inputs are 0. So what is the output? Minus 30. So output should be what? And x0 is plus 1. So out should be 0 because it's a negative 1. So if 0, 1, it again 0, 1, 0 is again 0, 1, 1, it becomes 40. 40 minus 30 becomes what? 10. So the output is 1. So this is the output. This circuit gives this output. So if somebody is there from electronics domain, or you apply your brain, you can say that this is what it is. What it is? It is AND gate.
And again,
So you can find out the AND gate. Similarly, if you put W0 is equal to minus 10, so here instead of minus 30, put minus 10. So here also you would be getting 1. So it becomes OR gate. And similarly, if you put only one thing and you put the weight is equal to 10 and the W1 is equal to minus 20, it becomes NOT gate. So this particular circuit, this particular thing becomes a AND OR and NOT circuit. And you know that, and using AND OR and NOT, you can create any kind of circuit. Okay, any kind of circuit. If you any logical circuit, if you want to build using, you could build. So this is the power of this kind of circuits. Okay, so we have talked about this, that equation, this particular thing represent an equation. This equation represent a decision boundary, and one side there is a positive region and the other side there is a negative.
Oh.
Yes, any problem with it? Any questions? Okay, so let me design a perceptron for this kind of classification. It's an interesting question. Okay, please see. Design a perceptron for this kind of classification. I want this kind of classification. So 0 0 0 0 1 1 1 0 1 1 1 0. If I want this, so this, let's assume that this is what the perceptron I have, x1 x2 and w1 w2 w0. So what I want, so w0 plus w1 into this 0, this 0 should be less than 1, then only it would be 0. If I put 1 over here, it should also be less than 0. This would be greater than 0. Can you see this? 1 0 1 0 1 0 with multiply with the weights 1 1, it should be less than 0. Now let me solve. Use the equation 1. So here in this equation, though both the w's goes away, so w1 should be less than this. Let me take the w1 is equal to minus 1. Second equation, w0 plus w1 should be less than 1. So let me take w2 also minus 1. Third equation, w0 plus w1 should be greater than 1. Let me take w1 is equal to 1.5. Okay, w0 is minus 1 now. So what I add over here so that it become greater than 0. So 1.5 I have to add. Third equation, summation of all these quantity less than 0. So by choice it is actually less than 0. So the answer is minus 1 minus 1 minus 1. So weights, you now you know the what are the weights, you put it here. So this is the perceptron that does the this kind of classification. Then comes the neural networks. Neural network says that you apply multiple neurons so that you can increase the power. The idea is this, that you put the, there are various level. So one perceptron, right now we know the perceptrons. Let's assume that these are the input values. Then 4 perceptrons are here. Then again 4 perceptrons are there. Then 2 perceptrons are there. Let's assume that I put into this particular way. This perceptron is going to be connected to all the things into the previous one. Here also they are connected to all the things over previous one. And this is how, when I build something, it is called the neural network. So you might be thinking that how many new hidden layers I need, how many these things are which are in between, they are called the hidden layer. The input is called the place from where you provide the input is called the input layer, and the place from where you get the output is called the output layer. So how many layers this particular neural network has? 3 layers, 1 2 and 3. Input is not layer because it does not have any parameter. So this has a parameter, this has a parameter, this has a parameter. So 3 layers, 3-layer neural network. So let me give this particular example to you. Can you give me a neural network for this, for the classification of this data? How would you proceed? So the idea is this, that actually idea is this, that when you know that a single line is not going to work, yes or no, a single line is not going to work. So in those cases you put multiple lines. Okay, let's assume that I draw 3 lines, and if I draw 3 lines, I can develop a method that whether line 1, line 2 line 3. I can develop a logic that whether the item is above the line line 1 or above line, let me say that line 1, line 2, line 3. Okay, so to be a negative item, the item should be here. Okay, what does it mean? That if I write that line 1, line 2 and line 3, if I draw this thing, for that line 1, for it is this particular region is above the line 1. For the line 2 it is below the line 2, am I right? For the line 3 it is also below the line 3, am I right? Then it is 0. In all other cases it is 1. In all other combination it is 1, am I right? Yes or no? Hmm? Yes or no? Nobody is telling. So please please let me know that you are able to understand this. So what I was telling, that I draw 3 lines, yes or no? 1 line, 2 line and 3 line. This is clear?
Yes.
To find out this particular region, to specify this particular region, I say that the region that is above the line number 1, below the line number 2 and below the line number 3. Is there any area that is below line number 2, below line number 1, 3 and above the line number 1? So only this is the area. Here I say that you output 0 and all other cases you output 1.
Okay.
So I have 3 lines, and for these lines I divided that where it should be up or down or what. Based on that I have decided that this should be the thing. So how can I design the neural network? So x1, x2 are input. 3 lines are there now. For one line I need how many perceptron? 1 perceptron. So I put 3 perceptron. Let's assume that they are going to decide that whether the line is the point is up to this line or below to this line. They are going to decide on this. On that I have to apply a logic, and that is a AND logic. You know that to apply a AND logic only a single circuit is sufficient. So I apply this thing. This is going to find out that whether this particular item is into this particular setting or not, and after that I apply a output layer and give the output. So this is the justification of this kind of architecture. So this is what the architecture that I have. It can give me the answers. Neural networks are actually applicable in the
Question,
case. Yeah.
sir, hidden layer 2, why do we need there?
Say again.
That can directly be the output, right?
Okay, yes, definitely. I agree with you. So you are telling that from here, this is not needed. Okay. Am I right? If I understand
Yes.
you correctly, you want to tell that this is not needed. From here itself I get the output, na?
Yeah, hidden layer 2 itself is the result set, right? I mean,
Correct. Yes, this can also be possible. However, I have placed it into to show you a general setting where I say that let's assume that here, let me say like this, that let's assume that these are the red point and these are the red point and all other points are green. Let's assume that all other points are green. How would you make now? Now you can draw a line like this, draw a line like this, draw a line like this, draw a line like this. Then by this, whether this belongs to here would be specified by this one. Whether it belongs to here, for that I have to apply another neural network. And 1, 2, 3, 4, 5, 6, 7, 8, 9 regions. So I have to increase this here also. And after that, I have to apply another logic to find out this. I agree with you. Yes. Yeah. Okay, so neural networks are applied when a long training time you can provide, but fast evaluation is needed. For example, into autonomous vehicle, where when something comes in between, immediately the system should apply the brake. However, it takes 1 year to build this system. It is fine for us. Okay, and it can fight with the training errors also, and that's a very interesting kind of result. So next thing that actually I would not go into that particular detail, and I also don't see that it is part of this, but just the next part is just for your understanding. Okay, this part, let's assume that in our course. Next part, I'm just going to tell you. So a few minutes back, I told you that what was happening, that error were actually that there was an problem with the error. And what was the problem with the error? That error was not continuously reducing. Okay, a few minutes back, when I saw that particular slide, error were coming up and down. So this is not a good idea because, to go ahead with. But for example, if the data is not linearly separable, it would keep fluctuating and go till infinite. Where to stop? I don't know. So it would be better if I can get some method which actually says that it is going down into this particular way. If something going down into this particular way, again I can apply the same method. I can find out the elbow and I can tell that I would not train beyond this particular point, and now looks like that this is the better parameter for us. So to do in this particular way, there is a method called the gradient descent we can apply, and gradient descent actually uses the direction of the steep descent and goes into the reverse of that particular thing so that it can minimize the error. There's a mathematical basis for that. So if you it actually utilizes one thing, that instead of applying thresholding, it can say that I could directly use the value and I can train the things into this particular. This was a fantastic approach, but however, mathematically, what happens that if you develop the thing, put the things into layers, what happens that essentially, for example, this is a neural network. Now, if you try to compute that, what is the output that is given by this particular kind of neural network? So ultimately, you come up that with a different kind of weight, a single perceptron could also give the same kind of output, which the output was given to me by this circuit. What does it mean? It means that neural network has collapsed to a single perceptron. So this is not a good idea because we are actually losing the power. To retain this particular power, we must apply some kind of non-linear activation functions. Various choices are there: sigmoid, tan, soft plus, and rectify. They have their own advantages and disadvantages. So using them, if you build a multi-layer perceptron, you would be able to train the system using back propagation, and this is the algorithm for back propagation. And there is a derivative also, that is also our scope of our today's discussion, that how this particular algorithm becomes better. And again, we have actually talked about that when we are training, now my error is going to reduce into this particular way. On the training, error is going to reduce in this particular way. On the testing, the error is reducing in this particular way. Why it is like that? So after some time, what happens when the data becomes the system becomes very good at training data, then it loses the scope of generalization. Therefore, it is going to induce. So we must stop before that particular point to give the better accuracy to our system. Here is a coding example that you can find out from this particular link. And I strongly suggest you that you please run this particular Jupyter file. You can see that here, this is an example. You can see that it is a data where two moons are actually inside. So what is going to happen, that finding out the classification become difficult. So linear regression give the things into this particular way. But if you build a system in this way, for example, here there are two values, x and y are input, and then there are two values as an output. So they actually specify that what is the class that I have. So here into the hidden layer, I'm going to increase the things, increase the number of neurons. If I put one neuron, so my circuit within one neuron, my circuit is this, which is very equivalent to the logistic regression. But if I put two, then it becomes something like this, something going to be better. Three, I think it is best. So you know that this is the best thing. Okay, it gives you this kind of decision boundary. 4, it becomes even better, even better, even better. But then you can see that it actually becomes very specific to the data. Therefore, it loses the chance of generalization. Here is a code. So I suggest you that you please read this. You by yourself, please execute once, and you would be able to see this working. That's all for today. Thank you very much. I have not gone to the details of this proof, and that is not needed. And if you are interested to see the proof, I always welcome you. As I told you that there is a full course on this ML that actually I have taught long back. go to the resources, you can find out so many things over there. So all these slides you can go and get more details. For example, here you can see the neural networks. So there are 3 lectures and videos are also available